inside between the two rings here would see themselves rotating side by side, and some of their field would cancel. Let's look at a cut view of that machine. This is a cut view of the actual magnets. You can see the slug magnets. It's south pole, north pole, and the field around it like looping like this, and a swirling motion. These magnets, as it spins around, sees that magnet spinning in the same direction, but some of its field seeing it at different vector angles. Remember, vector angles, also moving vector angles, and you can see the X's right behind there, demonstrating that these magnets' fields is continuously changing and opposing in sometimes at different places in time. Let's move on. This is a better view of the top of that machine. You can actually see the individual rings here and the slug magnets. Now, why are you telling me that? Well, because this machine also took off when he put it in motion. He realized that static electricity started to build up around the machine, so he could hear it crackling. As it started to rise, it actually took off some of the dirt under the machine. It rose in the sky and never saw it again. Let's move on. Pause here. This man is unfortunately passed away 2 months ago. To me, he's one of the most incredible inventor that I've ever met. His name is Mr. Floyd Sparky Sweet from the USA. Mr. Sweet was the inventor of the machine called the vacuum triode. A lot of people says, well, why don't you make it into a smaller size? Well, he did. He did it very well too. He understood that magnets were more than just a block of ferrite with magnetic properties. He knew that it was alive inside. There was a way of doing things with it. So what he did is he took 2 slabs of magnets, barium ferrite, same stuff that I told you about before, 4 by 6 inches by ½ inch thick, and put them into this configuration. Let's show the configuration here, Dwight. Okay, top view of this machine. We'll pause here, Dwight. This is the top view of this machine. That's okay. This is the slab of magnets I told you about. There's another one underneath. 2 coils, 2 more coils on the outside. These ones are wound like the ones you just saw from the Wilbur Smith winding, bifilar winding they call it. And these are just normal electromagnetic coils that just works at 60 hertz. So what they do is they take an electromagnetic field and then it cancels out right in the center because this field is opposing this one right in the middle. And this is the input coils. This one takes in 300 milliwatts, puts out 500 watts in the same wires that you put the input in. So you have to isolate your wires with capacitors, but your output will come on wrapped on that wire at the same place. Let's move on to different views. This is another view of that same machine. We'll move on to the next one. Now, this one is nice because you can see the side view of this machine here. And it's not a very big one. It was about a couple of pounds, 2 to 3 pounds. And this is the one that was actually tested by some engineers from NASA. And this thing works. Now, the reason why they gave it to this test engineer is that he could install a switch where that takes the input and puts it into these coils there so that the machine can be self-sustained. He did so, and it certainly did sustain. The machine ran 24 hours a day with the light bulb on it and never stopped till they gave it back to this gentleman, Mr. Floyd Sweet. Let's move on to the next slide. Now, the next, we'll pause here. This is a film that was done in 1987, and you can see the machine right behind it here. All you have is 2 slabs of magnets. The coils are inside. Now, of course, when you have something like this, you can see that it doesn't take very long to come up with brighter ideas of ways of reducing the size and so on. But the fact that the magnets were resonating was very important, so he never changed his magnets. He always kept the magnets there, but the coils became smaller because he realized that they didn't need to be big because the electricity was so different. As he actually activates this, you can see that he has some equipment underneath and at the back there to monitor exactly what he's doing. This was tested by Mr. Bearden, the man that I told you about, the rocket scientist. And this guy says that well, there was no jokes there. There's no batteries or whatsoever. These are 5 100-watt light bulb, 120 volts. The little machine at the back there is the one that powers up these 4 ones here. This one's off, and we'll run the tape. Now, this tape is much longer, but you can see here in this view, the fan. It runs lights like normal electricity. The fan was there. And then here, this is a close-up of this actual machine. And when he puts his hand on it, you can see the actual size. Now, we're going to pause there, please. What's funny about this machine is that the more power you take out of this one, the cooler it gets. The more power you take out, the less it weighs. When you take the wires on the outside there and you short them together, instead of getting a big arcing of light and carbon, you get snow. The wires goes to snow. That is another unusual effect of these machines. Let's move on. Another man from Vancouver, John Hutchinson. This man is alive still and has come up with things that are absolutely flabbergasting, really. Things that you wouldn't believe that were possible. John is from Vancouver, as I said, and he's an experimenter. He's a researcher. He doesn't have any degrees, but he sure knows his stuff. So John thought that by using Tesla's technology, he could come up with some unusual effects that Tesla did at the time. He was not aware that it would get the actual effects that we're going to show you here. Let's move on. This was a clip from a Japan television station. Okay, we'll move on. We'll stop here. You can see the carton board rising in the sky there, and the bowl didn't. John would get these unusual effects from some things sometimes that would just go right up, and the weight of the object, the size of the object, would not have anything to do with it. So John did a lot of experiments like this. Now we'll show you something else. We'll show you this in slow motion. Go ahead, Dwight. Now that was an empty carton milk carton. This bottle here is empty, and you can see the bottle. It looks like the air actually kind of rarefies or change temperature so that the bottle actually collapses and it comes back to its original position. Now there's no heat machine around this thing. All we have is 2 Tesla coils, one at 6 feet from each other, a Van de Graaff machine producing electrostatic field, and that's it. Now this is ice cream in a cup. John used to love doing these type of experiments because he thought, well, let's try everything. So he would tie paper and ice cream and ice and water and all types of things like that. Let's move on. You can see the ice cream taking off before the cup actually does. You can see it, and then the cups lift off. Look at this nail remover here. It'll lift off before, but the ball weighs 25 pounds, and she lifts off before the nail remover does. We'll pause here for 2 seconds. The movement back and forth of this metal steel ball, about 6 inch in diameter, weighs about 25 pounds. You can see the actual movement. It looks like if it was made out of styrofoam. This is all proven, by the way, ladies and gentlemen. There's no fake here. We have like hours of these tapes of different things happening, and it's been tested as well by scientists, and it's real. As far as why it's happening, we're starting to put out some theories, but right now we still don't know exactly what's going on. Momentum is part of it, gravity is part of it, molecular structure is part of it, atom structure is part of it, but we're still trying to come up with some answers. Now look at the ball's movement, and you'll see it looks like if it was made out of styrofoam. Let's roll. Now, we can't forget this weighs 25 pounds. And John would get these effects like 8 times per hour, for example, objects that would break apart and so forth. Now, we'll pause here 2 seconds. Dwight, can we go back a little and can pause this, please? This is important. A little more. Thank you. Let's move on. When you see the actual block, please, would you pause on it? Thank you. This is a block of pure aluminum. Look at the piece of paper right beside it. Right in the corner here, you can see the aluminum actually bubbling. That comes off the aluminum, and it forms a little puddle on the piece of plywood that's underneath there. Now, note the piece of paper here is not scorched. This aluminum is in a molten state right now. Look at the way it's going to move, and the aluminum dripping off of it, showing that this aluminum is actually changed state and cold. So now we have melted aluminum cold. Let's look at it some more. Let's roll it. Now you can see the aluminum just dripped there. Look at the jello. Look at this piece of aluminum. It vibrates like if it was made out of jello. John says that when he stopped the machine and go touch the actual aluminum, which is back now to its normal form, he says it feels cold to the touch. That's why the paper does not get scorched. Okay, we'll stop here 2 seconds. Japan, 1995. The last big earthquake that they just had. What you have here is tectonic plates in Japan under the sea, and some scientists thought, well, if the tectonic plates are pushing at high pressure, there's got to be magnetic field being, a movement of magnetic field being generated. So why don't we just suspend a coil in the water up there, and then let's see if we have an effect. They did. 10 hours before the big earthquake, they had effects. The unusual effects of this is as the plate moves in, and the effects are taking place here, the clouds on top of it starts to blacken and align, form lines, and the lightning starts to be created. Remember? Opposing magnetic fields, stressed magnetic field, different vectors of magnetic field, effects happening outside of the area where the magnetic field is being opposed, and somehow electrostatically or producing lightning effect and so forth. All again and again and again everywhere around the world. We're repeating the same darn thing. Let's move on. We'll see what it looks like. Now you can see the plate moving in here. I'm sorry this video was really bad. That's the pressure zone, and then it releases these magnetic waves, magnetic frequencies, low, very low magnetic frequencies. And then those are the effects they found somehow in the sky. Well, it's insulated with water. How can we get electrostatic field up there? Well, somehow it did. We're going to see the clouds here. That's the coil that the scientist, had put together. Really, it could be a speaker coil. It's the same thing. And we'll pause here for 2 seconds. These are the clouds. You can see the clouds blackened all over the area, and the lightning occurring in the clouds. They said that